Write the partial fraction decomposition of the rational expression 8x plus 7 over 2x minus 1 cubed. Now, since the term in the denominator is cubed, then to decompose it we need to provide three partial fractions. In other words, our partial fraction decomposition is going to look like some number a over 2x minus 1 plus some value b over 2x minus 1 squared plus some value c over 2x minus 1 cubed. So now we have to solve for a, b, and c. So the first thing I want to do is multiply both sides of the equation by the LCD, by the lowest common denominator, which is 2x minus 1 cubed. So I want to multiply both sides by 2x minus 1 cubed. So on the left side, the 2x minus 1 cubed is going to cancel out, and we're left with 8x plus 7. And then on the right, what I'm going to do is I'm just going to distribute this 2x minus 1 cubed into each term. So in the first term, we're going to be left with a times 2x minus 1 squared. For the second term, it's going to be b times 2x minus 1. And then for the last term, the 2x minus 1 cubes cancel out, and we're just left with c. So now we want to set up an equation. So we want to simplify the right side of the equation. So the first thing I want to do is FOIL out that 2x minus 1 squared. So let's do that on the side. So we've got 2x minus 1 times 2x minus 1. This is going to become 4x squared minus 4x plus 1, right? Yep. So we get a times 4x squared minus 4x plus 1. So we can erase all this. And then what I want to do is distribute this b into that difference. So we get b times 2x, so 2bx minus b plus c. And then finally, I want to distribute this a. So we get a times 4x squared minus 4ax plus a plus 2bx minus b plus c. And now notice that this has to be equal to 8x plus 7. So since these guys are equivalent relationships, then all the coefficients for the x terms have to be equal to 8, and all the coefficients for the constant terms have to be equal to 7, and all the coefficients for the 8x squared terms have to be equal to 0. So let's group all of the x squared terms together, all of the x terms together, and all the constant terms together. So there's only one x squared term, so that's 4ax squared. Then for the for the x's, we got negative 4ax and 2bx. So grouping them together and factoring out of an x, we get 2b minus 4a times x. And then finally for the constant terms, we'll group those together. We get a minus b plus c. So now we get to solve. So since there's no x squared term on the left side of the equation, then this x squared term here has to be equal to 0. So 4a has to be equal to 0. So a must be 0. So now we've solved for a, and now we have to find another one. So now let's take a look at the x term. So since the coefficient in x is 2b minus 4a on the right side, and the coefficient for x is 8 on the left side, then we know, since these two expressions are equal, that 8 has to be equal to 2b minus 4a. And since a is equal to 0, that means that 8 has to be equal to 2b. So then dividing both sides by 2, b has to be 4. Great, so now we've solved a and b, and the last thing we need to do is find c. So notice that on this constant term here, a minus b plus c, for the same reasoning, has to be equal to 7. So we have 7 is equal to a minus b plus c, and then plugging in what we know, which is a and b, 7 has to be equal to 0 minus 4 plus c, and thus c has to be equal to 7 plus 4, which is 11. So finally, we want to write down our partial fraction decomposition. So we had 8x plus 7 over 2x minus 1 cubed, and then going up top, it was supposed to look like this, right? So this is supposed to equal a over 2x minus 1 plus b over 2x minus 1 squared plus c over 2x minus 1 cubed. But we know that a was equal to 0, b is equal to 4, and c is equal to 11. So plugging those in, and then finally simplifying, since we have a 0 in the numerator, that cancels out. So the final partial fraction decomposition is going to be 4 over 2x minus 1 squared plus 11 over 2x minus 1 cubed. So that's what this equals.